Subscribe TG2. Graphics processing units, or GPUs, often excel in AI applications due to their architecture and parallel processing capabilities. Here are a few reasons why GPUs are well suited for AI. 1. Parallel processing. AI tasks, such as training deep neural networks or running large-scale simulations, often involve performing the same computations on multiple data points simultaneously. A GPU is designed with hundreds or even thousands of cores that can execute these parallel computations efficiently. By dividing the workload among numerous cores, GPUs can process vast amounts of data in parallel, significantly speeding up AI computations compared to CPUs. 2. Matrix operations. AI algorithms, particularly those used in deep learning, frequently involve matrix operations. The GPU is optimized for matrix calculations, utilizing specialized hardware and libraries to perform these computations efficiently. With their high memory bandwidth and parallel architecture, GPUs can handle the large matrix operations involved in AI tasks more effectively than CPUs. 3. Large memory capacity. AI models often require large amounts of memory to store data and parameters. GPUs typically have dedicated video memory, VRAM, separate from the system's RAM. The substantial VRAM capacity of GPUs allows for efficient storage and retrieval of the extensive datasets used in AI, minimizing the need for data transfer between the GPU and CPU. 4. Availability of GPU libraries. GPU manufacturers provide libraries and frameworks specifically tailored for AI and deep learning tasks. For instance, NVIDIA offers CUDA and CUDNN, which provide programming interfaces and optimized functions for GPU computing. These libraries enable developers to leverage the parallel processing capabilities of GPUs and accelerate AI computations. 5. Increasing hardware advances. GPU technology continues to advance rapidly, with manufacturers developing GPUs specifically optimized for AI workloads. However, while GPUs have shown significant advantages for artificial intelligence, it's worth noting that CPUs still play a vital role in AI applications. CPUs are better suited for tasks that require complex decision-making, single-threaded performance, and managing system-level operations. In many AI workflows, CPUs and GPUs are used together, with CPUs handling tasks like data preprocessing, model orchestration, and overall system management, while GPUs focus on the computationally intensive AI calculations. Subscribe for more videos. Thanks for watching.